Okay. So there were two special kinds of triangles, if you remember back to geometry. I know it's been a while. But the first triangle, good. The first triangle was a 30, 60, 90. And it doesn't matter which acute angle you label as 30 and which one you label as 60. So in this triangle, ABC, I have A as 30, B as the 90-degree angle, C as 60. So what you're going to do in a 30, 60, 90 triangle, you're going to look at the 30-degree angle. We'll start with that one. And you're going to say, okay, which side is across from the 30-degree angle? B to C. So that is going to be labeled as X. So across from the 30-degree angle is always X. Then you're going to say, you're going to choose the side that's across from the 60-degree angle. The side across from the 60-degree angle is the side AB. And that is going to be represented with an X root 3. Then you're going to find the side that's across from the right angle. What do we call the side across from the right angle? The hypotenuse. That's going to be a 2x. Okay. But this doesn't mean the bottom of the triangle is always x and the height is always x root 3, because I can change where the acute angles are. So let's say the 30 was down here and the 60 was up here. Let's call this triangle QRS. So in this time across from the 30 is QR, so that's the X. Across from the 60 is RS, so that is your X root 3. And the hypotenuse is always the side across from the 90-degree angle, which will be 2x. So you don't always say, okay, well, the bottom of the triangle will always be x. That's not true. You have to look for the angles and decide which side is across from it. So this was our 30, 60, 90. Now let's talk about our 45, 45, 90. Those are the two special triangles. All right, in a 45, 45, 90 triangle, I'll call this triangle LMP. You have a right angle, and then the acute angles are both 45 degrees. And in a 45, 45, 90 triangle, the sides that are across from the 45, so one side across from a 45 is LM, that's going to be X, and then across from the other 45 is also X. So basically in a 45, 45, 90, the legs are X, and the hypotenuse will be X times the square root of 2. You need to memorize these triangles. You want to memorize these triangles. Okay, so now for the purpose of, for our purposes in this class in pre-calc, we're going to be creating all these triangles using the unit circle. So let's write this out. Since we will be creating all of these triangles in the unit circle, x will equal 1. So if x is going to equal 1 in a 30, 60, 90, across from the 30 will be 1, across from the 60 will just be root 3, and across from a 90 will be 2. Since x is 1, right? And in a 45, 45, 90, across from the 45s are both 1, and across from the 90 is root 2. Okay, so let's see how we're going to work this into trig. Is everybody done copying? So my directions for this next part will be to evaluate. And the first one I'm going to have is the sine of 30 degrees. So we're going to evaluate this without a calculator. So I'm drawing my unit circle. Well, I'm drawing my axes and we're thinking unit circle. Now we know this is 0, 360, this is 90, this is 180, this is 270. Do we agree the 30-degree angle will end up in quadrant 1? Right, because quadrant 1 is from 0 to 90. So I'm going to go ahead and I'm going to draw my 30-degree angle, and then I'm going to drop an altitude down to make a right angle. So I have a right triangle. Now, because I have a 30-degree angle and I have a 90-degree angle, someone tell me, how do I know that my last angle must be 60 degrees? Good, because if you add up all the angles in a triangle, it has to add up to 180. So if I have already 30 and 90, it would only be a 60 that would add up to 180 with that. So now that I have a 30, 60, 90 triangle, I'm going to say to myself, well, I know across from the 30 is 1. I know across from the 60 will be root 3, and across from the 90 is what? 2. So now I'm bringing it back to SOHCAHTOA. This sign says you're going to pair the side opposite over the hypotenuse. Everything is in reference to this 30-degree angle. So I'm going to base this all off my 30-degree angle. The side opposite 30 is 1, and the hypotenuse is 2. So the sine of 30 degrees is a half. Okay, let's go on to the next one. Cosine of 120 degrees. All right, do we agree cosine of 120 brings us into the second quadrant? Right? So this would be like our 120-degree angle, but we never want to use the obtuse angle, right? So what am I going to do? Good. I want to find this angle. So what I'm going to do is I'm going to do 180 minus 120, which is going to give us 60. And then I'm going to drop down in altitude to make a right angle. So once again, what have I created? A 30, 60, 90 triangle. It's always going to be either 30, 60, 90 or 45, 45, 90. It's going to end up being one of those. So here I have my 30-degree angle up here. Now we know across from the 30 is 1, across from the 60 is root 3, across from the 90 is 2. So a lot of students, not a lot, a handful of students messed up on this on the quiz, which I still have to give back and we have to go over it. But after you find all the sides in the triangle, you then have to go back and see which numbers should be negative. So I found all sides positive, but then I want to see which one should be negative. So right now, above the x-axis, is that positive y or negative y? Positive y. Below the x-axis, that's negative y. So this root 3 stays positive. But to the left of the origin, isn't that negative x? So this one should be negative. And the hypotenuse should always be positive. So this is the only negative here. So now I'm going back to SOHCAHTOA. Everything's going to be in reference to our 60-degree angle. And for cosine, we're going to have our adjacent, which is -1, over our hypotenuse, which is 2. All right, next one. I'm going to have the tangent of 225 degrees. Is anybody still copying cos?
Don't you know already that it's 45 because it has 5 and you subtract 3?
That's good. Very good. Okay, so we have to figure out which quadrant we're going into. So this is 0, 360, 90, 180, 270. Good. We're going into quadrant 3 because 225 is between 180 and 270. So remember, where do you always make your angle from? You always make it from the origin, and then you draw your perpendicular to the x-axis, never to the y-axis, always to the x-axis. So do we all agree I need to find this angle that I just highlighted in green in there? All right, so the full angle is 225. How am I going to find just this angle in here?
You subtract
180 from?
235.
225, you got it. So we're going to do 225 minus 180, and we are going to get 45. Yes, Nico.
So always subtract like the x-axis you're on?
Yep. Or add.
Was it negative?
Yeah.
Yeah.
Okay, so now for 45, 45, 90, opposite the 45s are 1 and 1. Opposite the 90 is root 2. But after I fill in the triangle, what was the step you guys were sometimes forgetting? go back and figure out which sides need to be negative. So you tell me, is the hypotenuse, Stephanos, is the hypotenuse ever negative? No, never negative. So which sides here are going to be negative, and why? No? The ones, yeah. Why are they going to be negative? Because we're negative x to the left of the origin, and we're negative y below the x-axis. So these are going to be the negatives. So we're going back to SOHCAHTOA. Everything's in reference to this green angle 45. And so tangent of 225 is going to be the opposite, which is -1, over the adjacent, which is also -1. What's a negative divided by a negative? Positive. So the tangent of 225 is +1. You finish copying? Okay, next one. So now we're going to have the secant of 150. All right, which quadrant are we making this triangle in? 2, quadrant 2. So I'm going to drop my perpendicular. Obviously, we need this angle right in here. So what should I do? 180 minus 150, which is going to be 30. So we're dealing with a 30, 60, 90. You all tell me opposite the 30 is what number? 1. Opposite the 60 is √3. Opposite the 90 is 2. Which number should be negative? The √3. The √3 should be negative because we're negative x. Now remember, we're going back to SOHCAHTOA. Now I'm not thinking cofunction. Cofunction is different. The secant is the reciprocal of which function? Secant, not cofunction. Cofunction is what we did yesterday. Good. Secant's the reciprocal of cosine. Cosine. So now we know cosine is adjacent over hypotenuse. So what does that mean for secant? It's hypotenuse over adjacent. So the secant of 150 is our hypotenuse, which is 2, over our adjacent, which is -√3. Can I leave it like this? No, we need to rationalize. So I'm going to multiply top and bottom by √3. So the secant of 150 will be 2√3 over -3. Is it okay if you want to assign that negative to the numerator instead of the denominator? That's fine. Is it okay if you sort of want to just leave the negative in the middle? That's also fine. It really doesn't matter. Nico?
So depending on the angle you're given, you either have to subtract that angle from 180 or subtract 180 from it.
Yes, whichever is bigger. Because you don't want to end up with a negative angle.
Yeah, sure.
So it's always whatever's bigger. Still a couple things I have to show you. Okay, so here I have the cotangent of 495. 495 is way too big. So what I want to do is I want to find the smallest coterminal angle. Remember from the quiz, right? How do we find the smallest coterminal angle? We subtract 360, exactly. So I'm going to put a star, and I'm going to say find the smallest positive coterminal angle. So we're going to do 495 minus 360, which is going to give us 135. All right, so again, we're in quadrant 2. To find my reference angle, I'm going to do 180 minus 135, which is going to give us 45. Very good. So now we're at a 45, 45, 90. Opposite the 45s are 1 and 1. Opposite the 90 is root 2. Only one of these numbers is negative. Which one's negative? The bottom one. The bottom one is negative. So do we all agree cotangent is the reciprocal of tangent? So if we're back to SOHCAHTOA, we have tangent is opposite over adjacent. So that means the cotangent will be adjacent over opposite. So my cotangent of 495 degrees will be my adjacent, here's my reference angle, my adjacent is -1 over the opposite, which is 1. So the cotangent of 495 is just -1. All right, you guys try this next one. Cosecant is the reciprocal of what? You got it. Is this your last day with the flower babies? Yeah, it's done.
I get mine next.
You get yours next week? Yay, more flower babies.
You can't have a negative angle, right?
Hmm?
You can't have a negative angle, right?
No, we don't want a negative angle. Yes. Sure.
No, so I would just, anything divided by -1 is just a negative, so just be -√2. But if you left it like this on the test, you get full credit.
You're fine. All right, we're ready to go. Oh, do you have a question? Go over it. Okay, let's go over this. So we're at 315. So we are 0, 360, 90, 180, 270. So we have finally made it into the fourth quadrant. So now we're going here, we're making our triangle. And how do I get my reference angle right here? Oops, let's highlight. How do I get this reference angle? We're going to do 360 minus 315, and that's going to be 45 degrees. So we're dealing with a 45, 45, 90. Across from the 45s are 1. Across from the 90 is √2. Now, which one is going to be negative? Just the y. So now we're going to SOHCAHTOA. And in the beginning, we reminded everyone that cosecant is a reciprocal of sine. So sine is going to be the opposite over the hypotenuse. So cosecant will be the hypotenuse over the opposite. So when we have the cosecant of 315 degrees, it's going to be the hypotenuse, which is √2, over the opposite, which is -1. In all fairness, if you wrote this on the test, I would give you full credit, but what's anything divided by 1 is itself, anything divided by -1 is the negative version of itself. So cosecant 315 degrees is -√2. Yes?
Did you go in quadrant 4 because 315 degrees?
Because of the 315
Okay,
degrees,
I
yep.
like quadrant 2.
Yep, so you always have to put it in the right quadrant because that will change your signs on the sides. All right, 3 more problems. 3 more problems and we're done. So we're still evaluating. So now this is saying 3 times the sine of 150 degrees squared. So remember, even though the squared is on top of the sine, this is the same as saying 3 times the sine of 150 degrees squared. So where do you think we're going to start here? Aaron? Good. We have to find the sine of 150. We start inside our parentheses. So we're going here. Which quadrant am I working in? The second quadrant. If it helps you, I'll put the 0, 360, 90, 180, all that good stuff. All right, so at 150, we're going to do 180 minus 150, which brings us to 30 degrees. This is my reference angle. So now we know we have a 30, 60, 90. Across from the 30 is 1. Across from the 60 is root 3. Across from the 90 is 2. Do you need to memorize these triangles? Yes. Only one of these is negative, the root 3, because to the left of the origin is negative x. So now I'm going to have 3 times the sine of 150 is going to be the opposite, which is 1, over the hypotenuse, which is 2. I just used SOHCAHTOA. So sine of 150 is 1 over 2, but then we're going to square it. 1 squared, a half squared is a half times a half. What's a half times a half? 1/4. So now we have 3 times 1/4. And when you multiply fractions, you just multiply across. 3 times 1 is 3. 1 times 4 is 4. So our answer is 3/4. All right, 2 more. Sine squared of 240 plus the cosecant of 150. Oops, no, this is wrong. Sorry. The cosecant of 150, right, we're going to do 5 times the tangent. Maya would have been so mad at me. Sorry, Maya. 5 times the tangent of 135. All right, first we have to evaluate the tangent of 135 and the cosecant of 150. So let's go ahead and do this.
Isn't the cosecant 152? That's what we just did.
Good, because we did the sine. Very good. All right, so we have the tangent of 135, so I'm going to find my reference angle. 180 minus 135 gives us 45. So across from the 45s are 1 and 1. Across from the 90 is root 2. Not 2, square root of 2. Ion. Wasn't Matt. Matt's been focused. All right, only the x is negative. The one on the x-axis is negative. So the tangent is TOA. So we have opposite, which is 1, over the adjacent, which is negative 1. But then isn't it 5 times that? So 5 times a negative 1 is a negative 5. We're not done, because now we still have plus the cosecant of 150. We just found the sine of 150, so if you remembered that and you wanted to just change it to its reciprocal, you could. Or we could do it all over again. So again, we're in quadrant 2 because of the 150. This becomes a 30. And in a 30, 60, 90, across from the 30 is 1. Across from the 60 is root 3. Across from the 90 is 2. This is negative. Why is it negative? Oh, we're good. So now we're opposite, which is a half. Oops, sorry. Opposite, which is 1, over the hypotenuse, which is a half. So now when we come to add, I have 5 plus 1 over 2. In order to add, what must I create? Anybody know? In order to add, what do we have to create? Common denominator. So my common denominator will be a 2. In order to get that 2, I need to multiply top and bottom by 2. So I get negative 10 over 2 plus 1 over 2, and that's going to give us negative 9 over 2. Oh, I did sine, not cosecant. That's why you were confused, Matt. Oh, I'm sorry, guys. I did the sine, not the cosecant. You thought you were wrong? No, I can't be perfect all the time. So cosecant is hypotenuse over opposite, which is just 2, which makes this problem a lot simpler, doesn't it? We didn't have to make a common denominator, but for the next one you do, so that's okay. It was good practice. So we're negative 5 plus 2, which is negative 3. Sorry about that. All right, ready to try one on your own? Yeah? All right, last one, doing it on your own. It's a little bit harder because you have to make a common denominator. That's the only thing that's harder. Sine squared of 240 minus 2 times the cosine of 240. Are they opposites? Yeah, one's opposite hypotenuse, the other. Oh, you mean cofunctions? Yeah, they are cofunctions, but in this scenario, it doesn't matter that they're cofunctions.
What is the square root again?
So this is the same as saying the sine of 240, and then you find it and then square it.
I'm still confused how you classify
where to go.
You use, because like
do you
315 is closer to 360 without 240.
No, so 240 is between 180 and 270, so that means you're in this quadrant right here.
Okay. Are you excited for the weekend, Salva?
Always excited for the weekend.
St. Patrick's Day.
It's nice. I'm not Irish. And I don't drink. So not my favorite. Eh. Yes, I can.
No, you're in the right quadrant, but you always use the x-axis. So the angle was 240, and the closest x-axis is the 180. So you're going to do 240 minus 180. You do 270 minus 240. You use the y-axis. So you found this angle right in here. You don't want that angle. You want this one. No, always use the x-axis. Anybody need my help?
Squaring a fraction and just so there's no
Oh yeah, what? You're okay.
Is the algebra a little bit hard here? Yeah, that's okay. What happens when you square the top numerator and denominator?
Oh,
So
it's
then-
top model.
Yeah, both get squared. When you square a fraction,
okay, I was
both
going
get
for
squared.
this, and that's why. Okay, so this
Well,
yeah,
we
didn't
did
change.
square it, because 1 squared is just 1.
Yeah. Okay. Oh, so just
Guys, and what happens when you square a radical? It's just the number underneath the radical, right? When you square a radical, it's just the number underneath the radical?
Just that. I'm gonna have to get further. I have to change
Change it.
So just 7.4.
Yeah.
Okay, cool. Thank you.
Should we go over it? Okay. So maybe this one was a little bit harder.
Is that?
Yeah. So we're 0, 360, 180, 270. So when we're looking for 240, that brings us into the third quadrant. But remember, you're always going off of the degree in the x-axis. So here, when we do our subtraction to find our reference angle, we're going to do 240 minus 180, which is going to be 60. So that's our reference angle. Across from the 30 is 1, across from the 60 is root 3, across from the 90 is 2. In this scenario, both our 1 and root 3 will be negative. Okay, now what do? We find the sine of 240, so that's going to be the opposite, which is negative root 3 over the hypotenuse, which is 2. But remember, it was sine squared, right? So we have to square that. So now I'm going to have negative root 3 squared times negative root 3 over 2 squared. If it makes you feel better, you could write it like this. You could just write it out twice. So negative 1 times negative 1 is a positive 1. Root 3 times root 3 is whole number 3. 2 times 2 is 4. So this first part of the problem is 3 over 4. That's not my answer, because there's a whole second part of this problem. Right, the second part of the problem, luckily we're using the same triangle, but now this time we have 2 times the cosine of 240. So we're back to the 60-degree angle. Cosine is going to be the adjacent, which is negative 1, over the hypotenuse, which is 2. So now I have 3/4, was it plus or minus? Minus, okay. Minus 2 times negative 1 over 2. So let's keep going with this algebra. Now, what do you guys like? Do you like cross simplifying, or do you just multiply across? You multiply across. So if you multiply across, 2 times negative 1 is negative 2. 1 times 2 is 2. But what's negative 2 divided by a positive 2? Negative 1. So now we have 3/4 minus a negative 1. What does this double negative make? A positive. Matt, am I going too fast? Are you keeping up? You're good? Okay, so now I have 3/4 plus 1. In order to add these, what should I create? Common denominator. So I have 3/4 plus 4/4. I just multiplied top and bottom by 4 here. And that's going to give us 7/4. And we are done for the week. And you drop Monday. Lucky you.